So let's play with this again. So we're going to find the Maclaurin series for this expression. So there's things inside the angle, and it's being divided by an x. So I'm going to go slow. So cosine of pi x cubed. So I get -1 to the n, pi x cubed all to the 2n over 2n factorial. So I'm going to take a moment to fix this up again. So n equals 0 to infinity. So I still have -1 to the n. Being careful, right? So I'm distributing this to this and this. So I'll have pi to the 2n and then x to the 6n. Make sure you see how that happens, right? 2n distributes to the exponent of the 1 of the pi, and 2n it distributes, multiplies times the 3. So then I have 2n factorial. Okay, so this is cosine of pi x cubed. So now I want to take and divide it by x. So I'm going to write this thing down again. So -1 to the n, pi to the 2n, x to the 6n, 2n factorial, and so if I'm dividing it by x, it's like saying I'm multiplying it by 1 over x, right? So how do we take care of or combine these exponents of these x terms? I subtract. So I have -1 to the n, pi to the 2n, x to the 6n minus 1, right? There's this 1 down here, and then 2n factorial. So that's the Maclaurin series for cosine of pi x cubed over x. All right, so let's do it again for this one. So you know e to the 2x squared will be 2x squared to the n over n factorial, using your memorized Maclaurin series. So let's fix this up. So I'll have 2 to the n, x to the 4n over n factorial. So now, dividing by x squared, so 2 to the n, x to the 4n, n factorial, x squared down here, combining these two x terms, I'm going to subtract exponents, so I get 4n minus 2, and there it is. All right, so let's play it with another multiplication. So e to the 4x will be 4x all to the n over n factorial. So then I'll have 4 to the n, x to the n factorial. So now let's multiply by x to the 4th. 4 to the n, x to the n, x to the 4th, n factorial. So combining those x terms, so I'll get x to the n plus 4 over n factorial.